Today I'm going to be teaching you about the density. So what is density? Density is defined as mass per volume of an object, of a matter. So here's the equation. Density is equals to mass and divided by the volume. So the best illustration for density is water. So the density of water is 1 grams per ml or 1 grams per cubic centimeter. So if an object has less density than the water, then that object will float. But if it does have greater density than the water, then it will sink. So let me just write what I'm saying here. So if it is less than the density of the water, then it will float. And if it's much greater than the density of the water, then it will sink. So let's take an example here. Okay, let me write the density of the water. So 1 grams per millimeters. It can also be 1 grams per cubic centimeter. So a 100 gram rock has a volume of 8.5 ml. What is the density of the rock? So using this equation, density is equals to mass over volume. We can just plug in everything that we know. So the density is what we're finding for. The mass is 100 grams and the volume of the rock is 8.5 ml. Why my water's favorite? So dividing this thing, so we got 11.7 grams. Okay, 7 grams per mole per ml. Why do I always saying things that doesn't make sense? Well, so a rock has a density of 7.9 grams per ml. If the volume of the rock is 500 ml, what is the mass in kilogram? There is actually rock, there's a typo. So density is equals to mass over volume. So our density is 7.9 and our volume is 500 ml. So cross multiplying, we will get 3,950 grams as our mass. So what we're going to do here is just convert this into kilogram. So I got 1,000 grams and 11 kilogram here. 1 kilogram. So we can just cancel the grams and we will get this answer, 3.95 kilograms. So this is the mass in kilograms. Then let's solve more problems. The dimension of rectangular coiled matter are 6 cm by 8 cm by 9 cm. If the bar has a mass of 4 kilograms, what is the density of the bar in grams per ml and kilograms per cubic meter? So we all know that the volume is going to be length times width times height. So there. And what we're going to do is just convert this into cubic meters. So the centimeter will cancel. So I actually have a video on how to convert cubic meter and cubic centimeter. So this is the volume in cubic meter. So now what we're going to do is calculate our density because we already have the volume. So we got 4 kilograms on the top and 0.432 cubic meters on the bottom. So using our calculator, we will get 9.23 kilograms per cubic meter. So this is the first answer for that thing. So now let's get the grams per ml. In order to do that, we need to do so many things. So in 4 kilogram, and we have 0.432 here, we need to use conversion process. In 1 kilogram, there is 1,000 grams. I'm gonna put it on the numerator. And then in cubic meter, what we're finding here is ml, right? So as we have 1 ml, that is equals to 1 cubic centimeter. And then 1 times 10 raised to the third power of cubic centimeter is equals to 1 cubic meters. And then we can just say that 1 ml is equals to 1 cubic meters, right? Because they are equal. So we'll just put it here. There you go. So now, these things will cancel. Not the grams, but the kilogram will cancel. The cubic meter will cancel. Then, we can just plug in this value. So I got 9.25 to 9 grams per ml. And that is the answer for that problem. So they are just close. Wow. They're pretty close on each other. A 25 kilogram stone is placed in a cylinder with water. The volume of the fluid rises from 8 ml to 21 ml. Calculate the density of the stone in grams per ml. So we have a stone here that was put in a water, and then the fluid just rise from 18 ml to 21 ml. So we're just going to calculate the density of the stone. Density of the stone? What are we going to calculate? Okay, so the volume is just the final volume minus the initial volume. So our volume is 3 ml. So that's it. We got that. So our mass is 25 kilograms. And then using the formula, we can just calculate it. So we got 25 as our mass and our volume is 3. We can just divide this. So what we got here is 8.3 kilograms repeating. Then we're just going to convert this into grams because that's what is the problem wanted for. So again, we just have 1 kilogram at the bottom and 1000 grams on the numerator. So we can just cancel these things. So we'll get 8,333 grams. Okay, we still have more numbers per ml. So this is the answer for this problem. That was not hard, right? A spherical ball of radius 5 cm has a mass of 15 grams. Will the ball sink or float in water? So we already discussed this earlier. So if it is greater than the density of the water, then it will sink. If it's less than the density of the water, it will just basically float. So what we're going to do here is just calculate its density and then compare it into water. So we're just going to plug it in the formula of a sphere. So if you have taken geometry, you'll just know this formula. So we got this. So our volume is going to be, I'm gonna put all the numbers so we can just be precise. Okay, now we can use the formula now. So the density is equal to mass over volume. So our mass is 15 grams and our density is going to be 523.5987756. So using our calculator, we can just divide this. So we got 0.03 grams per ml. I mean cubic centimeter. So let's just compare this. As the density of the water is going to be 1 grams per cubic centimeter or 1 grams per ml or many more, we can just add more. So it is just basically less than the density of the water. So what will happen here? This ball is going to float. It is not going to sink. That's basically the answer for this problem. Now let's get to this problem. The density of diamond is 4 grams per ml. and 1 carat equals 0.2 grams. If an 8.5 carat diamond is added to a cylinder containing 54 ml of water, to what volume will the water in the cylinder rise? So we have the density, and we have 8.5 carat is equals to 1 carat and then 0.2 grams. We're just calculating the mass here. So we can just plug it in into our formula. We can just cancel this thing. So we got 1.7 grams here. So that is basically our mass. So to calculate our volume, we have this. The change in volume is just equals to the volume. So to what volume will the water rise? So that means we're looking for the final volume. So as the density is equals to mass over volume, we can just plug in our numbers here. Okay, so our density is 4, our mass is 17. Cross multiply, we got this. So 4 divided by 1.7, what will we have? We will get 0.425 as our volume per cubic ml. And then we can just plug it in here. Our initial volume is going to be 54 ml. And we're just going to add this. So what we got here is 54.425. So this is the final volume after we add the diamond. So it doesn't increase that far, but it still does increase. The density of metal is 2.7 grams per ml. If the length and width of 1.8 kilogram metal bar are 5 centimeter by 8 centimeter, then what is the height of the metal bar? So as density is equal to mass over volume, our density is 2.7. We're just going to plug it in. And 1.8 kilogram is our metal bar. But we have the given of grams in grams. So we're just going to convert 1.8 kilograms into grams. So we will get 1,800 grams. Okay, so let me just delete this. So we got 1,800 grams as our mass. And then we're looking for the volume here. So we got 2.7 V, 1,800. Dividing both sides, we will get this value, 666.6 repeating 7 cubic centimeter. So using that formula, so as ml is equal to cubic centimeter, this is going to be our answer. So as volume is equal to length times width times height, our volume is 666.6 repeating 7. Our length will be 8 and width is 4. So dividing both sides, we will get our height as 16.67 centimeter. And that's basically it for this video.